Hi, I'm going to talk about my experience with 3D printing. So, I made a mallet finger orthosis that fits my ring finger, as well as a swan neck orthosis that also fits the same finger. And so first we went to the 3D printing lab, and luckily an employee there named Steven helped us out a lot. Several of us had shown up around the same time, so he showed us all at once, kind of like after doing the measurements where we needed to measure, showed us step by step how to design it. And it was very informative. And once you have the base design, what I really like about 3D printing is that it's easy, quick, and cost effective compared to the thermoplastic. So I'm trying to imagine designing this curved edge that goes around the end of the finger with thermoplastic, and I'm foreseeing issues. I'm sure it's possible. I haven't tried it, but I'm foreseeing issues with getting it to bend without like corners forming here or any ridges forming. And so once you do have the base design down, this is all you do is update the measurements for your patient, and it's a much more cost-effective way to, and because making this little piece of plastic is pretty cheap, the plastic itself, the materials, is cheaper than the thermoplastic. As well as for the swan neck, I cannot even imagine how I would create this with thermoplastic. I'm sure it's possible. I'm sure you would cut the template, but I'm just imagining so many issues with draping, getting the temperature just right to make sure it doesn't like lengthen or anything. Because I remember doing a big orthosis was hard enough with certain types of thermoplastic material. So that's something I think is very beneficial about the 3D printing for orthoses. I think they came up pretty well. For some reason, I don't know if you can see it, the mallet splint came out very bumpy and ridged. So I did have to do a lot more sanding of it than with the swan neck. This one came out a bit more neatly, and I didn't have to sand it down as much. I can tell that it's effective. It's preventing hyperextension of the PIP joint. For this one, it seems very effective preventing movement of the DIP joint. And I wanted to talk about one experience I had with a prior student of mine. He actually had a mallet finger deformity from a ball hitting his finger, and the school nurse gave him one of these generic off-the-shelf orthoses, which I happen to have one from a previous injury, but I can still, because it's mostly Velcro and not that much of, plastic like here where it covers half the finger, I can still manage to do a little bit of DIP flexion. It's not completely blocking that. So that's kind of worrisome. I think if my student could have been made one of these custom fit mallet splints, it would have been way better for him and prevented re-injury, because he also wasn't very consistent in wearing his splint. And even if he was wearing it, I can still feel it, that I can move the DIP. And so that's going to prevent the tendon repairing as well. And so I definitely think it was a good experience, a beneficial experience. It was challenging to create the splints. We did kind of need help from the employees there. But once you have the base design down, you're good to go with it. And I can definitely see myself using this in the future. My two greatest interests are in working with hand therapy, as well as I'm also very interested in ECI, early childhood intervention. So for either of those two populations, I mean, obviously, if you're getting hand therapy, you have a type of deformity or hand injury, and having a custom fit orthosis is definitely necessary, as well as for small children. I could imagine it being very difficult for them to properly fit into an off-the-shelf splint, in which case also, if they have some kind of problem with their hand or fingers, a custom fit 3D orthosis would be very beneficial to them.